So, hello everybody. Welcome to this non-paper session, Research Infrastructures and Tools for Reproducible Data Communication Research. So, as organizers, there is Serge Frieder and myself present. Henning couldn't unfortunately make it to Coimbra. He supports us from the States. We have, in my opinion, amazing program. So we talk about first me giving a short overview, then me and Serge reporting on a Dachstuhl seminar we had last November, where we discussed about how should research infrastructures and tools look like to meet our needs. And the seminar came up with a number of interesting conclusions and recommendations. Then we have position statements from Serge, from Marie-José, from Sebastian, from Ethan. And then we assemble for a panel, where we also welcome Ellen. And hopefully we'll have fruitful discussions around that panel. Why did we suggest this non-paper session? So we said there are significant issues if we work in our traditional way to set up experiments that lead to scientific data. Typical cases, a PhD candidate has his way to set it up, produced for his paper certain things, and even in his group, when the PhD candidate left, the others say, we're not knowing how to continue working with that setup. We rather start from scratch, a new one. And it's also difficult to build on the results of what others had achieved, whether it's in the same group or in other groups. And what you see on this picture is a 6G conference that regularly happens in July in Berlin, where different groups show their artifacts. It's usually impressive, but none of the artifacts talks to each other. And it's so difficult if one group says, oh, this is interesting, how to combine it with our stuff. And this is how we say the research infrastructures should support us in a natural way, providing us with a software framework that makes it easy to build on others, that makes it easy to do reproducible research, producing high-quality data. This issue of reproducibility has been discussed in SIGCOMM for many years. It was my first activity as a young professor, suggesting this SIGCOMM workshop 22 years ago, where we all agreed as a community we have severe problems in reproducibility. Some people had some ideas, but it looked like this is a really tough problem because the problem didn't disappear. So there was 2017, another workshop, there were Dachstuhl seminars. So community understands certain ways how to approach the problem, but we don't consider the problem to be solved, but we have hope in the way being able to establish research infrastructures that come with software frameworks and all the things you need additionally to get the reproducibility and the ability to build on others' work in an efficient manner. One example where some people at this session can share their experience is this European effort labeled Slices that has a couple of ingredients where we believe they are reasonable as best practices to solve the problems I mentioned. We will have in our panel this set of people and a set of questions, how far are we at the moment in supporting experimental network research by such infrastructures in a way that they meet this set of needs that are among those where we think they are important and at the same time difficult to achieve. And with that, as an overview, I want to switch to the second slide deck. Which is kind of the summary of our Dachstuhl seminar with the recommendations. So the Dachstuhl seminars are usually kind of organized from a set of experts from different parts of the world on some topic. So we had also Kate Keehee, who is kind of the PI of a very large research infrastructure that also takes reproducibility as an important issue and supports it with reasonable or very interesting software frameworks. So for those of you who don't know what a Dachstuhl seminar means, in a remote part of Germany, close to Luxembourg and Belgium, there is a previous castle, which is now converted into a place where computer science gatherings can take place. It's subsidized. People who want to organize a seminar can suggest their topic, and there is a scientific evaluation, and they just try to get the most important topics that they get selected and run. Participation is by invitation, and kind of usually among the best experts around the world really come and attend the seminars. Also because it's an experience that it's really worthwhile attending. Many said these were among the best scientific events they did attend. And by the way, kind of, it's not only a castle, it's also a monastery type additional part of the building. So modern monastery architecture, but this spirit, what we also enjoy here, is somehow alive at Dachstuhl. So the people that gathered there, which included people from funding agencies from US and Europe, kind of concluded about, kind of after having severely discussed the different issues around large research infrastructures and testbeds, that yes, this is an important strategic investment. And together with the right community engagement, it brings ahead this discipline, kind of communication and computation research. And yes, it's also difficult to deal with these, with this format of having a research infrastructure, because you need sustainability. You need funding, not only for equipment, also for the people that care about it. And in order to be valuable and successful, the right support for open access to the infrastructure and a lot of support to have access to data and to build on that data that is generated in the research infrastructure is crucial, should be supported, and then creates the value. And there are other effects that are also considered important, which is kind of a means for collaboration, a means for achieving network effects, that if more people know how to set up experiments in a way that it's easy to understand other people's experiments or to build on them, this creates important additional value. In the seminar, we came up with a number of recommendations, kind of what to do if a research infrastructure is going to be a valuable one. Like, there needs to be the clear scientific objectives, not just piling a lot of computers networked together and say, dear scientists, use them and do something useful with it, but having well understood by which kind of concrete architectural elements the goals can be achieved. Then community is important, so supporting elements like PhD summer schools or other gatherings where with tutorials and good documentation are important. Then what the open science community with the FAIR principles, findability, accessibility, interoperability, and reusability of data research and of research data and metadata is concerned, this needs to be supported in an efficient manner, like having a platform with software tools that make it easy and automated to add the metadata. And having orchestration for the experiments such that the experiments are easily reproducible, because there are so many ways somebody can make a mistake so that the experiment is so hard to be reproduced by others. So guidance must be provided that the different people that would use the infrastructure really achieve the reproducibility. And the right multi-year investment with adding new hardware to it and having the right plan how to do it to keep the infrastructure always on the newest level is important. Then on a logical side, like having common abstractions, APIs to link software artifacts together. And another set of things like, if there are different research infrastructures that are in competition about who gets the next big amount of money, the right evaluation criteria need to be there. And that is also a hard problem, but should be thought of from the beginning when providing or building up a research infrastructure. And user experience, like how long does a fresh PhD candidate need to get his first experiment executed, would be important. And also, in some way, how flexible is it to support experiments that were not thought of at the beginning when the infrastructure was set up, and how to ensure sustainability. And who is interested in more details, there has been a lengthy report written by the people that were assembled for the Dachstuhl seminar, and you can get an overview in a video by the networking channel, which is also popular. With that, I would like to change the slide set to number 3 and hand over the mic to Serge.
I have only a few minutes, so I'll be, if you can. Yeah. They said this, so I guess I have to wait. I don't touch anything. So I will have 3 minutes. Yeah, the screen is changing here, but not here. Anyway, it's coming. So the world is changing, right? And I believe that we have to ask ourselves how this is going to transform our research, and eventually what is the impact on our community. I try to manipulate from here. Yeah, it works. First, we have to face a deluge of papers. This year, we saw a 20% increase for the submission at SIGCOMM'. I believe this is mostly driven by AI/ML. You will certainly check this in the program. Second, this has been mentioned by Georg, still, we didn't improve much with respect to reproducibility. Although you started long ago, and I know many put a lot of effort to try to address the problem. Third, do we still trust the result that we produce? And I think this is a big risk for science. Fourth, I used to do this very fancy exercise to account the number of papers at SIGCOMM', It's not a random choice. Accounting for the number of papers where you have at least one author from the big tech. It goes usually from 20% to 50%. This year, it's even getting into the trend that I bold earlier, because we see that 60% of the papers published at SIGCOMM' are from the big tech. 11 from Alibaba, congratulations. 11 from ByteDance. 14 from the US big tech. Another point which is very interesting is that we see an inflation in the number of authors per paper. What does it mean? What does it mean for academia? Does it mean something with respect to the cost for doing research and access to this type of facility that gives you a competitive advantage? In other domain science, experimentally driven research is the first-class citizen. They speak about thought experiments. So an experiment that will help you to provide evidence about an assumption. Very successful. You can see Nobel Prize in Physics in 2022 and 2023. How do they develop the community? Through what they call scientific instruments. I think you are familiar with these pictures. On the right, it's a collider, very famous for high energy physics, and on the left-hand side, it's a telescope for astronomers. Those are research infrastructure that are devoted to the science in those domains. Why do they need scientific instruments? Actually, 90% of the scientific papers published are using scientific instruments because you trust the scientific instruments and they are a reference infrastructure for doing the research. Also, it comes with a methodology. So you have to support the full research life cycle. So from the experiments to the collection of the data to, again, the assessment of the quality of that data and to reproducibility. Those are conditions for publishing papers in many communities. This is going even further now because AI is going to have a transformative impact in science at large, as, of course, in other domains of the society. Again, take a very simple illustration of this. Nobel Prize in Physics 2024, Nobel Prize in Chemistry 2024. So this is going to happen to us. Meaning that we also need to have access to data because there is no AI ML or whatever agentic AI if you don't have access to data. And how can you qualify the result that we produce if you don't have access to data, you don't have access to training, you don't have access to the models? Only a few companies will be able to do that. What is the impact on our communities? We can continue to live with this, everyone is happy as long as your paper is being cited, or that it raises awareness with the way that we produce scientific papers. It's a big problem because it's also how open should we be, which is the ethics of science. So we have to be open. And again, the tussle with competition, because as soon as you open, then you believe that this provides a competitive advantage to the competition. And this is, I think, a very important point that we have to deal with. The reason why we develop slices is because we believe that we need to equip the academic community with a scientific instrument similar to a telescope, similar to a collider, in order for you to develop a meaningful research that, again, can be trusted and can have a real impact for the academic community. Thank you. And I hand over to Marie-Josée, the new director of Slices RI.
Okay. Okay. Okay, so I think Serge probably said everything. So we're Slices. We're the RI for digital research, and I will tell you that I'm a North American, and I keep telling this joke because the first time I saw RI, for me, it was not research infrastructure, it was research and innovation, which shows that I come from another culture. So what do we want? Is actually design, develop, actually help design, develop, and deploy the next generation of digital services in everything. I have a thing about the science versus the technology here. I see us as technologists. We're not doing pure science, mathematics and stuff. We're doing a lot of technology. We want to support innovation. And for me, also very big important of these platforms, and Ellen Zagura is here, and I met her in the PAR platforms in the US, where we had a really strong goal of creating training and developing the next generation of, we call it HQPs in Canada, which is the highly qualified personnel, but the people who will continue the evolution of the systems. So the focus now is very much on digital technologies and services, a lot of data collection that Serge mentioned, cloud edge, federated AI, but in the future, we cannot get out of AI. So AI support, I call it in-network computing, when we start adding programmable data planes, distributed agents, that's the agentic stuff, and hopefully quantum networking. And the common themes around this are data and data sets, which again, Serge mentioned this pyramid of data, information, and knowledge, and actually we would like to be very much in the information and just raw data that means nothing, and reproducibility. Oh, okay, wrong direction. Okay. So I call Slices an internet of platforms. I created this because the name of the internet is running code and rough consensus. And I think with this 26 partners from 16 countries, rough consensus will be really cool. And of course, we're going to have a bunch of running codes from the researchers and the innovators. And just to tell you where we are, we're trying to create our MVP for the end of the year. And this is the elements of the MVP, and I could spend an hour on this, so I will not do that. But I was asked today to talk to you about a little bit of the innovation, this I that I thought was innovation. Of course, if we have this platform that people can connect to and run their experiments, I think there's a slight difference between Europe and the US. In the US, we think that PhD students are innovators and they're going to create startups. So yes, they can use our platform to do that. It will minimize the cost of innovation. Serge mentioned it. And I would like that this platform brings academia and industry together. This is from, again, this is from a PAR presentation at NSF, which talked about this valley of death between what's happening in the university, the science, and what's happening in industry, the technology. And there's somewhere that those two groups need to connect and stop having not only the valley of death, but what I often call the two solitudes. People in labs do not talk to people in industry, and vice versa. And I think because we're going to have these platforms, it can help bridge that gap. I'm going fast because I don't have a lot of time. Features of Slices, I'll just go fast. Project-based, of course, we need people to develop projects on it. It's top-down, it comes from the community of researchers. It's distributed and shared, of course, 16 countries, multiple platforms. Inside many of the countries, there's more than one site. Virtualized and efficient. A lot of times we will need to virtualize the access so that users can have a better access to it. And of course, compatible and scalable. And the future-proof, I should put that in huge letters because Slices is supposed to last until 2042, which is a very long time in terms of technology. Remember where you were in 2008? Look at your iPhone and think that this was the year the iPhone came out. Do you remember the world before the iPhone? Probably not. So this is the time frame that we're looking at. So in conclusion, because I didn't have a lot of time, we want to focus on advanced infrastructures and tools and digital research. My big thing is user communities. And I think what we did as a mistake in part is not having this access to the users early enough, at least in two platforms I can think of. Blueprints, which are this way of automating the research and helping people develop their experiments. Of course, data and data set, data as the fuel of the 21st century. And I think Serge also mentioned, and Georg mentioned, the reproducibility. And for me, again, SLICE's RI is research and innovation and to bring industry and academia together. Thank you. Oh, and no, actually, I have to thank everybody. Serge, because he probably recognized a lot of his slides there, and a bunch of people from the US, from my teams in SLICE's, from the people who are developing a Net4AI with me, the people in Canada that are my reference go-to for AI. And I'm always so happy that I'm actually privileged to have a number of great students who actually are so innovative and so actually who have allowed me to participate in their life quests. Thank you.
Okay, so this is the artifact evaluation. So this is the way of the ACM to actually try to raise awareness for reproducibility in our community. And these kind of badges are now awarded to papers that go the extra mile and make their research reproducible. Therefore, the ACM also defined that there are different kinds of levels of reproducibility, from repeatability to replicability, with replicability being the most independent kind of reproduction of experiments. So these were introduced in 2015, and these were, so this is an analysis of the SIGCOMM conference and the actual reproduction of experiments within SIGCOMM called the artifact evaluation. And here you see that over time, a different number of papers actually went for different kinds of badges. So from 2020 to 2024, we have roughly always almost the same level of kinds of paper that have prepared basically their artifacts for being available or functional or reusable or even reproduced. In 2022, the SIGCOMM moved away from the reusable and reproduced badge because it was quite a high effort to actually check and also for the authors to prepare their artifacts. But still, also this change did not really bring the numbers up, so we are always stagnating on the same levels. Also, other conferences do it, for instance, the ACM CONEXT. But also for this conference, we almost see a stagnating trend, with also the numbers for 2025 not being there because it's still ongoing. So what can we actually do, or what are the problems? So this is, for instance, one of the problems, that we need quite a lot of difficult to get hardware to actually do this kind of reproduction. So this is just an example from the year 2023. So several of them needed NVIDIA GPUs with quite a high price tag, I would say. Then there's also kind of requirements for different kinds of Intel Tofino switches. Then somebody wanted to have an Intel SGX capable CPU. Also, RAM is quite in high demand, so some of the machines or some of the experiments needed 512 gigabytes of memory or more. And then there's also the example from SIGCOMM'25 that needed a large amount of AWS instances costing over $1,000 just to reproduce a single experiment. So despite these challenges, there was also a study where the users and the authors and the experimenters were basically evaluated, and all of them usually found this kind of artifact evaluation useful and also interesting. However, they also found it quite time-consuming as the authors as well as the evaluators. So what could we do to actually improve this kind of process? So these are just some ideas how to improve it. So there's the ACM IMC. They have some kind of pre-approval process for the reproduction of papers where some reviewers have a look, and only if the reviewers basically give their go, the reproduction is actually done by the evaluators. Then you could also use testbeds that can provide access to this diverse set of hardware that we need to reproduce it. There's also kind of a lower effort if both authors and reviewers use the same platform, and this shared platform can then also make debugging quite easy. And there's of course the reproducibility framework that we try to achieve in slices that would also help to move this kind of artifact evaluation forward. And there's already some improvements. So for this year's SIGCOMM', we see that they already suggested to use a testbed, in this case the Cloud Lab testbed, at least for the reviewers. The authors could also use it, but it was not that much incentivized as for the reviewers. And there's also the improvement that the testbeds will actually guarantee that the resources will stay available for the foreseeable future, so it's also more easier to reproduce it in the future. So thanks, and I'll hand over to the next presentation.
I'm going to talk about our peering testbed, where we've confronted a number of the challenges and goals mentioned as part of the digital. This is something that Italo Cunha and I initially used in the final stage of our dissertation. We found it was useful, and with our current and former students, including Todd Arnold, who's here, we've worked to expand it and make it available to the community. So what is peering? So it's a network, or AS, with routers around the world and BGP connections to thousands of commercial networks. We have routers at universities and IXPs, and we've deployed routers in cloud data centers around the world and in Cloudflare POPs in hundreds of cities around the world. The functionality that it gives you is almost complete control of our autonomous systems, interdomain control and data plane. So you can make BGP announcements to influence how other networks across the internet route towards your experiment. You can select which networks of our neighbors to route through to reach internet destinations, and you can exchange traffic with internet destinations. The platform's open to the research community, and you can submit proposals for experiments at our website. The different classes of sites have slightly different subsets of that functionality, but in the interest of time, I'm not going to go into the details. So why did we build this in the first place? First, BGP is known to contribute to many problems on the internet, including security problems, performance problems, and availability problems. But we've traditionally had limited tools for conducting realistic BGP research. I'm going to go through a security example to show the types of limitations and what peering can bring. So in this use case, we're going to consider defenses against routing hijacks on the internet. We're going to ask how we can identify which networks are filtering invalid routes using RPKI. And it's not important that you understand the details of RPKI for this. So without peering, a traditional approach to this would be to look at measurements of existing routes on the internet. And you could try to find cases like this ASA that is announcing both a prefix that it's allowed to announce and also one that it's not allowed to announce. And then you could look for a vantage point like ASC that's using a different route for the valid announcement versus the invalid one. And you might then assume that some network that's on the route for for the valid prefix but not the invalid one is filtering the invalid route, in this case ASB. And there's been studies that worked like this. The problem is that this experiment is uncontrolled. We haven't isolated the validity status of the route as the only possible explanation. It could instead be that ASA is announcing the two prefixes differently, maybe for load balancing or resilience. Or it could be that ASC is choosing different routes for reasons unrelated to their validity, for example, load balancing or route age. With peering, you can instead simultaneously control both the validity status of routes and the announcements that you're making. For example, you could announce a control prefix C and an experimental prefix E. Initially, you could say that peering is allowed to announce both of them. You could then flip the experimental one and say that peering is no longer allowed to announce it. And if you observe some network changing its route, then you might be able to infer that the reason for that change is that it's filtering out invalids. So that's one example use case, but it's been used for a wide range of things in more than 50 publications, including a number at SIGCOMM over the years. The use cases vary a lot, but we tried to identify some common patterns. One is controlled experiments like that route security example I gave, where you're using peering to control aspects of routing in order to conduct a controlled experiment, or systematically varying routes in order to generate ground truth data you can use in a validation. Another common use case is in the wild demonstrations, especially of traffic engineering or of attacks and defenses. And then also BGP routes are only visible in measurements if they're being used, which gives you limited visibility into things like resilience, route diversity, backup routes. You can use peering to manipulate which routes are available in order to uncover hidden routes and understand more about the internet. We provide various types of data collection for our experiments. I'm not going to get into the details. I want to highlight a couple challenges in running it. One is that funding tends to be set up for supporting large new projects rather than maintaining incremental support of ongoing projects. So it can be challenging to fund and support it over time. Deploying new sites can be a headache, partly because of these staffing and funding issues. So love to have discussions with the community about how we can improve that. Love to have all of you submit experiments and use our platform. It gives you a foothold for controlled and replicable interdomain experiments. Thanks.
And now I would like the slides to be flipped to number 7 and that all the presenters join us on stage together with Alan. And as Ellen didn't have a position statement yet, I would hand over the microphone to her.
Thank you. And thanks all of you for being here in the audience. You can really sit in the back of the room in this room. Some of you are so far away, I can hardly see you. So I'm Ellen Zagura. I'm a longtime faculty member at Georgia Tech, and I'm a relatively short-term, although it feels like a long-term, employee, a temporary employee of the U.S. federal government working at the National Science Foundation. And I have found myself, though I didn't go for this purpose, I'm now like the big boss of all of computing at the National Science Foundation, which is frightening and exciting at the same time. So I'm mostly speaking with my Georgia Tech hat on, but I'm going to say, so I'm not going to tell you anything that comes from being specifically at NSF, but it has heightened my awareness of a number of things. And so I think the main thing I want to say is I think change is hard, and most people won't change unless they're in pain. And I think we may be on the cusp of some serious pain. And that from the standpoint of trying to get things like reproducibility and test beds to happen could actually be a silver lining. The two pain points, 2 or 3 that I'd point to. One is the 60% number. the 60% publications coming from industry. I think that is a significant, should be a significant wake-up call for academia. The second pain point, which won't mean much to the non-US people in the audience in specificity, but in abstract I think it will, is something called gold standard science, and the US folks may shiver a little bit when I say that. So this is an increased emphasis on replicability, among other things, an increased emphasis on replicability that US funding agencies are being asked to implement. And I think we potentially can use this as a lever to make the right things happen that have not been happening. So for example, you might see an increased scrutiny of your release of data from your experiments in the evaluation of your next request for funding, right? So tying the willingness to make data available to, in some ways, your success rate in obtaining future funding. That seems totally reasonable to me. So these are two kind of pain points that I think might actually result in us moving to a place rather different than we've been at. Nobody likes pain, but you know, it can be a real catalyst for change.
Who wants to address these pain points or add further ones?
On the 60%, I will turn back the question to you. I was at MIT for quite a long time, and a lot of our funding came from industry. So when we were publishing a paper, we had industry on our paper. It didn't mean that the paper was published in industry. It meant that we had a collaborator for industry. And looking at the papers here this week, I think there are some papers who could be in that category where the funding came from Google or from Meta, but actually the work was truly academic. So it's just that I'm not saying that the 60% is wrong, but I'm thinking that it may not mean that the whole work was done in industry.
So I predict that if we don't do anything, and again, I have nothing against industry. I used to work with industry a lot, but as a community, in 3 to 5 years, the number will be 85%, maybe 90%. That's fair. I mean, we can continue like this. European side, as you know, we like regulating. So, but of course, we have to balance regulation with respect to competitiveness. But for instance, yes, nowadays, what you got, when you receive public funding from the EU or from most of the member states, you have to follow open science. So meaning that you have to publish in open science venues, which is not always good. And also you need to read the data. That's a decision. Otherwise, you cannot justify the public funding that you received.
So I'd be very curious to hear people's ideas on incentives that we as the community can directly put in place. You know, it's great if NSF starts incentivizing things, but the more we can get out ahead of it, the better. And I think an especially important one to think about is incentives for students, where you know, students have a very limited time. I've found with a number of, you know, in recent years, it seems to take longer to publish more iterations on papers, which means that students feel the need to jump to a new project sooner, which makes it harder to maintain measurements over time, harder to put things in place to make them replicable, harder to make it easy to build on. So, you know, anyone from the audience or the panel, I'd love to hear ideas on what we should be doing within the community.
I think this was a good keyword, including the audience. Is there anybody having a question to the panel from the audience?
Hi, Clara Narstedt from University of Illinois, Urbana-Champaign. I have a question about entry. If in academia we want to access many of these shared test beds, how are we going to easy up entry to these test beds? Very often, a lot of our students sort of would complain that they spend a lot of time engineering the test beds before they actually can do any meaningful experiments. That's one. The second thing is when we want to do interdisciplinary research, for example, VR, AR researchers, video researchers into, for example, fabric or other sort of type of test beds, many of these other researchers, again, are commenting that many of these networking test beds are very hard to enter. A lot of expertise is needed to be built up. So I'm just wondering from the panel, how do we easy up so that we can produce faster results of large scale to compete actually with industry? Thank you.
Yeah, I can talk a little bit from our experience with peering and what we've done over time. I think there were probably 3 key things that we've done to try to make access easier. I will say that it's still somewhat of a heavy lift because, you know, nobody probably in this audience, unless anyone's worked as a network operator before, has experience running active BGP on the internet, and we didn't have it before we started running it, and so it is learning something new. But the 3 important things that we've done, one was Italo and some of my students, including Todd and Brandon, who some of you know, put a lot of effort into making our system maintainable. So we have intent-based configuration in our database. Adding an experiment is just a matter of clicking approve, and then it automatically pushes out the configuration to all our sites around the world to enable the experiment to access them. And that was a huge upfront effort from them, but over the years it's really paid off in making the testbed maintainable, where now it's, you know, Italo and his students spending a little bit of time maintaining things, and, you know, we don't have any full-time staffing on it. The second thing is that we have a number of different ways to use it, from a script that has examples that it just takes command line parameters. You can follow the examples. For running simple things, you can just use that, and you don't need to know how to set up a router yourself. But if you want to run something more complicated, then you know, you can just run whatever router you want. And supporting that, we have a capabilities framework that won't let newcomers do things that they shouldn't do. We only enable the capabilities that they need. The third is that we've automated some of the data collection so that you might need to learn how to run the specifics of your experiment, but that we can hand you some of the data that documents what happened. And, you know, we'd love to get feedback from the community on more we can do to support onboarding, more we can do to support packaging up experiments. Also, one thing that's worked well for us is having experiments add the new functionality that they want, and our researchers add it and then submit it to us as a pull request. And so we'd love to have people contribute in that way.
I can add something to this. In Slices, and Serge can probably talk about it better than me, we have something that's called a blueprint, which allows to automate a lot of the functions that would be necessary to run the experiment. And recently they've added an LLM to this, so you can actually specify your experiment without knowing exactly the number of this, you know, which antenna, which antenna number and which CPU number you want to use. And in terms of the multidisciplinary, I think it's my goal that, and one of my goals actually, that I would like us to federate not only within the federated learning inside our platform, but to federate with other platforms that have, in the list there's something that's called sustainability. There's a lot of other platforms that are looking at sustainability. We won't have the whole answer, but we can actually supply some of the data from the networks to the people who do sustainability. So I think there's also a proposal that we started doing last week with other platforms. Some of them are in biodiversity, and we can actually help with the whatever comes from the network that can help with that. So I think it's a goal, but Serge, you may want to add something on the blueprints or something.
Yeah, we did this. That's a very important question, and in DAX tool, that was one of the top KPIs, the costs to really be able to access the platform. So yes, in Slices, we basically try to start from the scientific question, transform it into a blueprint, and we did another exercise, which is very successful. we designed the blueprint to be processed by an LLM, together with other type of data, of course. And it's very efficient. So meaning that if you, of course, it is intent-based, because it cannot be meaningful independently of the question. But actually, if you talk to the LLM for that blueprint, it will be able to take you to the design of the infrastructure with the right parameters, pushing the code, collecting the data. So basically, we plan to use it as a control plane for the whole experiment. So far, it seems to work very well, but you need to design the blueprint accordingly.
Okay. There is another question?
Yes. Changing gears a bit, I think it was Serge who was presenting the idea that A, there's a lot more publishing coming from big tech, and B, that this is a justification that we need large public infrastructures, scientific instrument equivalents for engineers and our academia. And correct me if I'm wrong, but the premise that I'm taking away from that is that as a field, we are reaching a point where the problems we need to solve are so large that you can only meaningfully test them, reproduce them, or fix them if you are at the scale of a big tech company. And so academia on its own can no longer discover and solve those problems unless we can reproduce the same scale on our own. Is that a valid way to understand that argument?
It's a question to me?
Well, this is a premise to my question. I'm asking if I understood your point correctly before I move to the question.
You know, over the last 20 years, and your question is, of course, completely valid, but over the last 20 years, it was always the same question, because, of course, the scale has increased, and the diversity has increased, and the technology is moving forward. So it's always a way to explain that we cannot do it.
Right.
Again, when I designed slices, I had to talk with other domain sciences. Do you believe that it was not as difficult when you build those big scientific instruments? Do you think that the scale is not, and the diversity and the complexity of the technology is not the same?
With the point.
At the time of COVID, you remember, of course, there was a big issue with respect to competitive developments of vaccines and so on. Also, the community very quickly agreed to share data.
Right.
So, you know, I don't know. I don't know whether it's simpler or more complex in a domain or in other domains. In many, still, they have those large-scale scientific instruments. Doesn't mean that it's addressing all problems, that you can address all technology issues, that one size will fit all. But at least the community is structured and organized in order to address the challenges.
Well, I think your question is a really good one, important one. And I think clearly it's complicated, right? So maybe in industry there's more access to interesting problems, something that wouldn't likely be solved by building an infrastructure unless the infrastructure were operated in such a way that it revealed problems itself. So it could be that there are more interesting problems. It could be that there are more smart people. It could be that the evaluation, the ability to evaluate in a way that convinces reviewers is higher. I mean, I think that's the third one, is the one that research infrastructure is mostly attempting to solve. So, you know, you say have an interesting problem, you come up with an interesting solution, but if you haven't convinced the reviewers or yourself in that, you know, about the robustness of the solution, the validity of the solution in realistic settings, then, you know, you're stuck in a way. So I think it's the last one of these that is probably the most direct target of research infrastructure.
Right. Well, this was just
I just wanted also to add that I think one thing that is happening, and it happened in my career, when I was doing my PhD, there was very little PhD people who were going to industry. And think of the number of people now who are top researchers who work for industry. And that also may skew a little bit the way we look at it, because yeah, if you think of the people who won that Nobel in AI, are related to people I know who actually are not in academia. Think of Jan LeCun, who's at Meta. So there's a little bit of that skew that, again, I also come from Canada where there's very little money for research, public, so we have to look for the support from industry. So I think we should, I think it's a much more complex landscape than I think it could be. But I think we're running out of time, right?
I think one little quick thing on that too is we've been very obsessed with the problems from industry for a few decades, but I think that the symbiotic relationship we have with them makes it a little complicated because the majority of our students go to industry, and those students are often going to be much more competitive for industry jobs if they've interned in industry. And the internships want to attract students, the best students, and one way they do that is by trying to have them publish. And so, you know, I think there's some complexity in there. Like, on the one hand, there's something to be said for not working on the problems that they're obsessed with, and maybe then we don't need this, but if we're going to support the majority of our students, we maybe need to.
So I think even though a lot of people here would have additional thoughts about what to add, this might be a good measure of a nice non-paper session, that we're having enough material to discuss afterwards. And I think there is another non-paper session coming now. So I want to thank this wonderful panel for all the contributions, and I hope the audience enjoyed. Thanks.